Welcome to this tutorial on solving quadratic equations by completing the square. Now, just like we did with factoring, we need to get a zero on one side of our equation. And we like the biggest power of x, in this case the x squared, to have a positive coefficient, or a positive number attached to it. So we will build our zero on the left-hand side of this equation, and we will get everything else over on the right-hand side of the equation. So the 4 becomes positive, the 12x becomes negative, and leave a little space as we put the 3. Then we factor out whatever is attached to the x squared term. In this case, it's 4. And we factor it out from each thing that has a variable, but we leave our number alone. Then we complete the square. And when we do that, as we saw yesterday, we just take the middle term, or the x term, and divide it by 2. So we'll have x minus 3 halves being in parentheses that becomes squared. Now when we square 3 halves, the negative turns to a positive, 3 squared is 9, and 2 squared is 4. So that'll be 9/4. However, what we have really just included in this expression is 4 times 9/4, which is really a positive 9. In order for this expression to keep the same value, we then have to subtract 9 to counter it. 3 minus 9 becomes a negative 6, and now we have completed the square. Once we have completed the square, we need to solve for x. So we'll bring the 6 to the other side. Then before we take the square root, we have to divide by 4 on both sides, getting the parenthesed item isolated. Now we could take the square root on both sides. I know this can be simplified, but let's leave it that way for a second. Take the square root on both sides. Don't forget the plus or minus option. You need to have both of those. So we will have x minus 3 halves, because the square root and the squared cancel. Now this is really the square root of 6 on the top, and on the bottom the square root of 4 is just equal to 2. Keep your plus and minus options there. And now we will add the 3 halves to both sides, and when we do that we will end up with x is equal to 3 halves plus or minus the square root of 6 all over 2. That's our final answer if we were asked to solve for x. Overall, the process isn't bad. Complete the square after you get a 0 on one side, and then go through and solve for x. We will look at one more example though, and that other example involves fractions. Off with the x squared term being positive. So we'll build the 0 on the left and get everything else over on the right. We want to keep the terms with a variable next to each other and put the number off on the side. And now what we have to do in this problem is factor out the 5/6. The problem spot for this, for a lot of people, becomes what is going to be the x term that remains. There's two ways of looking at it, possibly even more. One way is, what would we have to put here so that when we multiply it by 5/6, we get 30? Perhaps you can find the answer to that question. Maybe it's a little tricky. The other way that you can answer that question is when we factor something out, we're really taking the number that we had, in this case it's 30, and we're dividing by what we factor out, which in this case is 5/6. And that turns into multiplying by the reciprocal. 30 divided by 5 is 6. 6 times 6 is 36. So it's going to be a plus 36x that we will put in those parentheses for this to all work. Now we actually complete the square. Okay, so what do we have to pair with the x in the parentheses so that when we square we get a 36? Well, it would be half of the 36, which is 18. Then when we square 18, we get 324. So we'll put plus 324 right here. Keeping in mind that we really didn't throw in 324, we have to multiply it by 5/6 to figure out what we just included in our expression, which should be 270. So to counter out adding 270, we then have to subtract 270 on the side, and a 7 minus 270 is going to give us negative 263. Okay, so now we have to solve this equation, now that we have completed the square. In doing that, just take it one step at a time. So we'll bring the 263 over to the left, equals 5 6 times the quantity x plus 18 being squared. To get rid of the 5 sixths, we could multiply by the reciprocal on both sides. So we're going to multiply both sides by 6 fifths. Please do not have decimals in your problem or in your answer. So on the left-hand side, either use your calculator, that's probably the ideal way, or think it through mentally. 6 fifths times 263 appears to be 1,578 over 5. Next, we take the square root on both sides. Remember, the square root over here is really the square root in the numerator and the square root in the denominator, but only put one plus or minus out front. So we're going to have x plus 18 is equal to, now we've got the square root of 5 in the bottom, and you might want to ponder for a second, is 1578 going to have a perfect square that divides it? The one that might jump out and kind of make me think it could work would be 4. If I take 1578 and divide it by 4, it doesn't divide evenly. So no, 1578 isn't going to have a perfect square divided, but we still have to rationalize. So we're going to multiply by radical 5 over radical 5. In the denominator, we get 5. In the numerator, it's still not going to be a radical that can simplify, because 5 does not factor into 1578. So we'll just multiply them together, and we'll get the square root of 7,890. One more step. We got to get the 18 over on the left, so we subtract it from both sides. And our final answer is that x is equal to negative 18 plus or minus the square root of 7,890 all over 5. Not the nicest of answers, but really, as you see, this process seems to work every time. Complete the square after you get a 0 on one side, and once you've done that, solve for x by using square roots. That's how we solve equations, by completing the square.